check this out, folks. What we're going to do is we're going to graph these things. Now, what we have been doing is we've been just kind of drawing what the graph might look like. But now we're actually going to put some numbers to these graphs and actually get accurate pictures of how this graph looks. So here's what I've got. I got myself a rectangular container. Why am I drawing one when I have a rectangular container right here?
It looks exactly like the drawing.
I know, it's perfect. All I gotta do is put a little, like a little thing right there, and then now it looks even less like the drawing because my drawing is horrible. Yeah, so it's a rectangular container. Can you dig it? All right, envision. All right, let's pretend that this container is. All right, let's see. It's more like this. And that's 3m, 5m, 8m. Wait, 3m, 5m, and 8m? A meter is about 3... A meter is like almost 3... Dude, that thing's like 20 feet tall. Okay, say that I got a giant room. Is this supposed to be... Oh, I guess meters. Alright, whatever. Kina wants to fill up a rectangular fuel container. Alright, dude. Or Kim. Kim wants to fill up a rectangular fuel container. And she does it at a rate of 15 meters per minute. And the first 6 minutes after the first 6 minutes, she got impatient and she just like cranked it up and put 20 cubic feet per minute. And you know what? Why would they give us 20 cubic feet per minute and give us 15 cubic meters per minute? I think that's a typo. Let's change that to cubic meters in our mind. The 20 cubic meters. Got it? So now here's what we got. All right. We got ourselves a giant graph. Now I have a question for you. How do you think this graph is going to look? Well, it's going to be a straight line that kind of goes up like this, right? And then at some point later, I know actually exactly at 6 minutes later, it is going to go up a little bit higher. The reason why it's going to have a greater slope over there is because it's being filled up with a greater rate. You got it? So here's a water faucet that's going inside that's dumping in water. So now what we're going to do is, yeah, exactly, Raven. We're going straight over here, straight with a diagonal. Because straight, you could have straight with a diagonal or straight across this line. Now, this thing is being filled up straight this way, and it's going to get bumped up like that. Got it? Now, what we're going to do is we're going to apply some numbers to this. So, at this point, this is the basic shape of it, but we don't know exactly what those numbers are. Got it? We don't know exactly how to draw a really pretty graph on this. And that's kind of what we're looking for now. So I know at time equals 0, so this is time, and this is the volume. At time equals 0, how much is it? How much is it full? How full is it? It is 0 cubic meters full. Because I didn't turn anything. At exactly 0 seconds, I didn't even turn on the thing, right? Alright. Actually, you know what? I think this might be a good variable to measure would be the height. So, all right, here. At exactly after exactly 1 minute, how high is this thing? After 1 minute, how much water did I put in? I put in, well, you read it right there. It says 15 cubic meters per minute. So you put it in for 1 minute, you put in 15 cubic meters of water, or fuel, or gasoline, or whatever this is, or diarrhea, I don't know. That's gross. Sorry, I apologize. It was kind of gross. I'm sorry. All right. So, how tall was this? If you have 15 cubic meters inside of here,
I'm so sorry.
how tall is this thing filled up to? Well, what is the area of the bottom? So the area of the bottom is 15, right? It's 3 times 5. That would be the area of this part right here. That's just the bottom of the container. But I want my volume to equal to 15, so I know that it must be a foot high or 1 meter high. Does that make sense? So at exactly 1 minute, it is 1 meter high. So there's some numbers that I can attribute to that. Let's see how tall it is at 6 meters, or at 6 minutes. How high do you think this up is going up? What do you think this value is? Which kind of means I drew the graph wrong, right? I can't see anything you're typing, I'm sorry.
She says, can you see what I'm typing?
I can see you asking me if I can see what you're typing. But that's it. Alright, so at 6 meters out, or 6 minutes out this way, it's going to go up to 6 meters up this way. Does that make sense? Alright, Liana, ask your question. I'll read your question while I'm talking about this. Now, yeah, you keep mentioning that you have a question, and there's like this giant blank space, and I don't see anything. Oh, wait.
Something's wrong with your typing.
You guys are typing with giant spaces. I'll tell you what I'm going to do is I'm going to maybe change the size of the font over here. But that means I won't be able to see it. That means you'll be able to see it. So you're going to have to tell me what they type because I can't see that.
Me?
And actually, did my computer just freeze? It froze.
It did.
The thing froze. It froze again. I didn't even get 6 minutes into this thing. I can't move my mouse forward. The thing froze. It looks like the video is still going, so let's just finish off the video for now. I'm sorry. This is the best I can do. Alright. At 7 minutes, how much water is in the container? So, look, at 6 minutes, how much water is in the container? That's my question. Well, that would be 15 times 6, right? Which is not 16. It's 15 times 6, which is equal to, you got a calculator? Yeah, you do. You have Google alone. Put 15 times 6. What does that equal? 90? 90 meters cubed? Got it? At 7 minutes, how much water is in there now?
15 times 7.
15 times 7? No. Because after 6 minutes, they dumped in, they turned up the volume, they cranked it up to be 1 more, or 20 meters per second. Does that make sense?
Mm-hmm.
Or 20 cubic meters per second. So they went from 15 and they were like, dude, this thing takes so long. So they're going to crank it up to be 20. So it would be 20 times 1 extra minute, right? Does that make sense? At 7 minutes, it's 20 times 1 because it's been at 20 for 1 minute. Plus, you got to add in the 90 cubic meters that is already in there. Does that make sense to you now?
No.
Huh? No?
Wait, you said you wanted me to type in something calculated?
No, I just figured it out.
Oh,
Too slow. All right.
sorry.
All right. Here's what I'm saying. I want to figure out. I know that the amount of liquid that is in here. Let's just call this the volume. I know that the amount of liquid that's in here is 90 cubic meters. Because if you fill it up for 6 minutes at 15 meters cubed per second, you're going to get 90 cubic meters in there. Agreed?
Yes.
In the problem, it says after 6 minutes, we got impatient and we turned this thing up to 20. So therefore, ergo, we are no longer just cruising along at 15 cubic meters per minute. We ramped it up. We have a bigger slope because there's more water coming out of the pipe. Does that make sense? So if I say, hey, how much is 7 minutes? Or how much water is in there after 7 minutes? You can't just say, well, that's 15 times 7. Because we've left this part right here. We're no longer at just 15 cubic meters. We turned the pipe up to 20. So therefore, we have to say, all right, well, at 7 minutes, so I'll just put at 7 minutes, so you keep in mind that that's the time we're talking about. it's been going at 20 for how long?
A minute.
For 1 minute. Got it? Plus, you have to add the 90 cubic meters that is already in there. Make sense? So therefore, you have to go 20 plus 90, which is equal to
110.
110. There we go. So at 7 minutes, this thing goes up to 110. So it would have gone there, but it probably goes up to here. So therefore, your graph gets kind of bumped up like that. And so you can put in the exact numbers. You guys understand how to do these numbers? All right. Here's what I got to do. I got to log out, log back in, get this thing up and running. I'll be right back, but I'm going to stop the recording and try doing this work.